Hello, and welcome to Fabric Espresso, your quick shot of insight into Microsoft Fabric. My name is Joanna Podgoetsky, and today I'm super excited to welcome Peri Rocha, who is a PM driving data ingestion and storage innovation in the Fabric warehouse. Today, we're lucky enough to have him dive into data clustering, which is a powerful new feature that will help make your queries faster. Hey, Peri.
Hey, Joanna. Good to see you.
Good to see you too. Cheers.
Cheers.
So, Peri, really excited to have you here. Can you walk us through what data clustering is all about? How is it going to benefit customers, and why does it matter?
So data clustering, what it's really about is making our queries run even faster on Fabric Data Warehouse. And we achieve that by organizing data on disk in a specific way. When you query your data and apply filters to select only a portion of it, clustering helps us open only the files that contain the relevant data ranges. And by organizing files this way, you can skip reading any files that don't contain the data you need. That leads to a major performance boost because arguably I/O is the most expensive operation in a database system. So if we avoid touching irrelevant files, we unlock huge potential for optimizing query performance.
That's awesome. So, effectively, you can eliminate huge chunks of data when you're actually reading the data. So, that's what gives customers that amazing performance, right?
Yes, indeed. Exactly. Say you have a table with 100 billion rows. If most queries only select, say, 100,000 rows or maybe 1 billion rows out of those 100 billion, we don't need to scan all of the files in your table. That makes your queries run much more efficiently, cheaper to run, and significantly faster.
Awesome. So, how does a customer know what cluster columns to pick?
So the idea behind it is you can look at your workload and you see, you repeatedly query a certain table based on a column that you often filter by that column. For example, say you have a sales table that has a sale date column, and you often look for sales items between the dates of January of 2025 and December of 2025. So if you often are filtering by that column, then you can cluster by that column, and you should see the benefits. Thankfully, I should say, not hopefully, we have something called query insights in Fabric Data Warehouse, which also helps you understand queries that you repeat often, so that you can, we can help you pick those columns just by looking at your workload.
Awesome. So, customers just need to look into their query insight, look at the query history, and that will help them pick the right cluster columns.
Yes, indeed. Yeah, that's the idea.
Good. Really cool. Well, let's have a look at a demo, shall we?
Wonderful. So what we have here, I have my warehouse, and we have a order items table here. You see, I have two copies of the same table. So I have an order items table that is a regular table, and I have a copy of this table here, which uses data clustering. The way you use data clustering is you introduce this clustered by syntax to the create table statement, and then you specify the clustering columns that you want to use. You can use, by the way, 1 to 4 clustering columns for data clustering. So these tables, they look the exact same. The only difference is one uses data clustering and the other one doesn't. So what I want to do, Joanna, is I want to go ahead and run a query here. So let me start this query. And this query is targeting our regular version of the table. So you see here, I'm selecting a few columns from the order items table, which is the table that does not use data clustering. And I'm applying a filter here on the sales order key column, which you might remember is the column that you're using for clustering here, right?
Mm-hmm.
So because this is well aligned with the clustering column, this is a good example on how it works. So we can see here, this is the regular version of the table. This is gonna take, I think, around 40 seconds or so. I've repeated this query a few times already. So should be nearing completion anytime now. You can see that you really want data clustering, right? Because this one took 47 seconds to complete, right?
Yeah, definitely want that a bit faster.
Yes. Now, I'll go ahead and run the clustered version. Now, this is the exact same table, the exact same data, except it runs on the data clustering version of the table, right? And take a look at this, Joanna. It took 3 seconds, right? So if we look here, the query execution time was 1.9 seconds, right? And it took a couple more seconds to actually bring the results to the screen. But the query execution time here was 1.9 seconds, where it took 43 seconds in the previous example. This is a massive difference, right, in between those two runs, if you think about this. And I should emphasize here, those are code runs. I did not warm up this environment. I didn't run these queries before. This is the first run of these queries, and that's the difference that we get from data clustering.
That's pretty impressive, going from 43 seconds to 1 second. That is incredible. I mean, imagine warm runs. That's really, really cool.
So remember how we were talking about query insights just now, right? And we mentioned that we have query insights that has all of the history of the queries in your warehouse. Remember, we were just talking about this, right? Yeah. Guess what? For these queries here, I tagged these queries here. I tagged the clustered version of the query with a label that says clustered, right? And yeah, I tagged the regular version of this query with a regular label, right? So let's have a look in Query Insights. Query Insights is exposed through the Query Insights schema. And we have a view here that's called exact request history. So what we want to do is we're going to select the label so that you can see, if it's a clustered run or if it's a regular one. So whatever was sent to the label property here will be exposed here in Query Insights on the label property, or the label column, I should say. The submit time, which is, we just ran it. The row count, so that you can verify that both queries have the same row count. By the way, those tables, they have 60 billion rows, those tables. And those queries return about 2,500 rows, but it's a 60 billion rows table, about 1 terabyte in size. We'll take a look at, how much, what was the elapsed time for both queries? We've seen it. It was 1 second and 43 seconds, I think. We'll look at the, the CPU time, because this has a direct impact in your pocket, how much you're paying for this query, right? And the most important, this is what will prove why data clustering is effective. We will see how much data was actually scanned from disk in each example. Does that make sense?
I love that. Using the power of Query Insights to see how much faster your queries are running with data clustering. This is where the magic happens.
This is where the magic happens. So let's look at the data. Okay, so there we go. So here are the runs. We just completed these runs. And what do we observe here? So the row count is the same. Once again, those tables, they have the exact same data. The only difference is one is clustered and the other one is not clustered. But check it out. The total elapsed time, this is in milliseconds. So it was 1.9 seconds. We observed this when we ran the query. The other one was 45 seconds. I keep saying 43, but it was actually 45 seconds, right? But check this out, Joanna. This is the really important part. The allocated CPU time for the clustered version was 39,278 milliseconds, right, in CPU time. So why is it different from this time? It's because, Fabric Data Warehouse, of course, is a parallel engine. And not only we have parallelism through the compute nodes themselves, but within each compute node, we have multitasking. So there are several CPUs working here at the same time in parallel to process your queries, right? So, but the regular query had about 2,500,000 milliseconds. It's a huge difference here in cost and how much this query costed you and how much this one costed you. It's, this is a direct impact on your cost of your query. And why this happens? This is the reason why. This is the total data scanned. And we can see here that the total data scan for the regular version is, an order of magnitude over the clustered version. It's about, 5%, 4-5% more or less of the data that was scanned. So the clustered version only had to scan about, 4-5% of the data that the regular query did. So this is where the rubber meets the road, and this is how data clustering delivers on these benefits. It's just by having to scan a whole lot less data, it needs to do a lot less work, and therefore it completes the query in less time and in less money. So that's the secret behind it. Does that make sense?
Makes sense. Love it. So customer just needs to give a little bit of information about most frequently queried columns, and they're going to get huge savings. absolutely massive. This is awesome. So excited to see this land. That was awesome, Peri. It sounds like data clustering is an absolute game changer for performance for the Fabric data warehouse. We would love to hear how folks are using this feature, so drop your thoughts into the comments. Feel free to share feedback through our ideas forum. Thank you so much for watching. We hope you enjoyed the video, and we really hope that you start using data clustering.
Thank you.